So, I want you to imagine for a second that you're staring at one of those really famous, mind-bogglingly vast James Webb Space Telescope images.
Yeah, the deep field ones, right.
Exactly, yeah. Usually those images make us feel incredibly small, just looking across billions of light years of empty space. But what if we've actually been looking at them entirely wrong?
Because what if you aren't looking at vast, empty space at all? What if, what if it's a flattened map of time itself?
And that is exactly our mission for this deep dive today. We are unpacking a super fascinating, a totally radical source document that basically reinterprets James Webb data through a six-dimensional perspective.
Yeah, it completely dismantles everything we think we know about, physical distance and linear time. It's wild.
It is. I mean, I am just so enthusiastic about how this source takes a sledgehammer to our basic 3D illusions.
It's definitely a paradigm shift because mainstream science looks at these images through a standard 3D or 4D lens, right? Space and linear time.
Right, exactly.
But we're going to use this source to step into the 6D realm. This is a space where the past, present, and future timelines merge into, what the document calls a single time crystal matrix.
Time crystal matrix. I love that term. So to really grasp this 6D perspective, we first have to destroy our 3D illusion of distance.
Right, we have to tear that down completely.
And we're going to start with that very first JWST deep field image, the SMACS 07231.
Yeah, that's a perfect starting point. So when scientists look at that image, they see what's called the past light cone.
Okay, wait. Define the past light cone for us real quick.
Sure. So because light takes time to travel, it has a speed limit. You're seeing a 13-billion-year-old galaxy right next to a 5-billion-year-old galaxy.
Right, because one is physically farther away, so the light took longer to get here.
Exactly. Science says they are separated by massive physical distance. But our source counters that with a really bold claim.
Oh, this is the part that broke my brain.
It argues this image is actually a 3D cross-section, like a literal slice of a 6D manifold.
Which means in 6D, distance and time just collapse. Those galaxies lose their physical distance, right? They're actually sticking together on a flat plane.
Yes. From a 6D perspective, the spatial distance literally vanishes.
Okay, the source has this brilliant analogy to make this relatable, and I have to bring it up. The glass sculpture.
Oh, yeah, the glass sculpture is a great way to visualize this.
Right, so imagine a giant layered glass sculpture where every single layer is a different era of time.
Right, a different slice of cosmic history.
Exactly. So from a 3D perspective, if you're standing to the side and looking at it horizontally, you see the gaps, you see the physical distance between all those glass layers.
But if you take a 6D perspective, which is like climbing a ladder and looking straight down from the very top, what happens?
The gaps just vanish. The layers compress into one flat, unified image.
Exactly. So JWST isn't looking across space. It's essentially looking down through the 6D time crystal.
That is just so wild. But why do we perceive distance then? For you listening right now, the illusion of 3D distance is pretty convincing.
Well, human survival basically requires the illusion of 3D distance. You have to know how far away a predator is.
Right. Biology demands it. But our consciousness doesn't.
Right. No, it doesn't. And that's what's so fascinating. Our inner witness consciousness actually operates a lot like this 6D structure.
Wait, really? Explain that connection.
Think about your own memory. If you recall a memory from when you were 5, and you process a thought you're having right now, and you plan for tomorrow.
Oh, I see where you're going with this.
Yeah, those don't exist miles apart in your head.
Yeah.
They exist simultaneously as electrical signals in the exact same neural space.
That is mind-blowing. Just like the galaxies in that 6D JWST image?
Exactly like that. The physical distance is an illusion.
Okay, so if time and space are compressed into this crystal, what happens when you subject that crystal to, extreme mind-bending forces?
Well, then we move from a beautifully flat image to a completely shattered one.
Right, and that brings us to Pandora's cluster, Able 2744.
Yeah, Pandora's cluster is where things get really intense. JWST sees galaxies there that are shattered, bent, and multiplied into hundreds of pieces.
And mainstream science just says, well, that's gravitational lensing, right? Just light being bent by massive gravity.
That's the standard textbook answer, yeah.
Okay, but let's unpack this, because our source pushes back hard. It claims this is actually proof of Hugh Everett's many worlds interpretation.
It does. It really goes there.
I mean, how do bent light rays equal parallel universes? That sounds like a huge leap.
It sounds like sci-fi, But the source uses this concept of the cut diamond to explain it.
The cut diamond. Okay, walk us through that.
So imagine this 6D time crystal holds all possible alternative realities. Every parallel timeline is frozen inside it.
Okay, I'm with you.
The source argues that these shattered galaxies we see aren't just optical illusions. They are literally different quantum possibilities.
Wait, so alternative realities are bleeding into our 3D world?
Yes, exactly. They're bleeding into our 3D
Oh,
membrane.
how? I mean, structurally, why does that happen?
To explain the why, the text leans on the Randall-Sundrum model.
Oh, right, string theory stuff.
Yeah. Basically, the model says electromagnetic and nuclear forces are trapped in our 3D world. They can't leave.
Because light is an electromagnetic wave, it's just stuck here on our slice of bread, so to speak.
Exactly. But gravity is the exception. Gravity can travel freely through the 5D and 6D space, which physicists call the bulk.
So the monster gravity in Pandora's cluster is doing what, exactly?
It's acting as a topological bridge. Because the gravity is so immense, it connects our 3D world directly to the 6D crystal.
Oh, wow. So it's essentially dragging those shattered fragments of parallel universes into our view.
Precisely. Gravity is pulling them through.
You know, for you listening, this actually connects right back to your daily life. It really does.
Oh, the quantum cognitive split, right?
Yes. When you're facing a really tough decision, your prefrontal cortex imagines multiple scenarios at the same time.
Right, you're thinking, what if I do X? Or what if I do Y?
Exactly. And all those possibilities exist at once in your head until you finally choose.
That's a perfect parallel. That quantum cognitive split happening in your brain is mechanically the same thing happening on a cosmic scale in Pandora's cluster.
So cool. Okay, so we've seen how extreme gravity pulls alternative realities together. But what does this entire 6D crystal look like if we zoom way, way out?
If we zoom all the way out, we have to look at the macro map of the universe, the cosmic web.
And this brings in the concept of the fractal universe from the source, which I absolutely love.
It's a beautiful concept. In nature, the micro always mirrors the macro.
Right, like the tiny branching veins on a fallen leaf matching the massive branches of the tree it fell from.
Exactly. And the expert analysis here takes that analogy and applies it directly to string theory.
Right, because string theory says there are like 6 extra dimensions curled up at every point in space.
Yeah, curled up infinitely small. They're called Calabi-Yau manifolds.
Calabi-Yau manifolds. So if the universe is a fractal, what does that mean for the macro scale?
It means the macroscopic cosmic web, that huge network of billions of galaxies, is just a giant replica of those microscopic 60 Calabi-Yau shapes.
That is just, wow. And this leads to the big reveal from the source document, doesn't it?
It really does. It concludes that the galaxies in the cosmic web are not scattered randomly.
Right. They are nodes in a static, completely motionless geometric crystal.
Exactly. So the sprawling web of galaxies we see is actually just a 3D holographic shadow.
A shadow, cast by a perfectly still, eternal 6D light crystal that holds all timelines. We're just looking at the shadow.
It's profound. And to synthesize this, the text brings up the research of scientist Franco Vasa.
Oh, right, Vasa. He's the one who mapped the brain against the cosmos.
Yes. He proved that the geometry of the cosmic web is a 100% match to the geometry of the human neural network.
100% match. That's not just a coincidence.
Not at all. The human brain stores memories and potential thoughts as a static electrical crystal.
And that is exactly how the 6D universe stores its cosmic memories. That is just staggering.
It really connects the cosmic to the deeply personal.
It does. Okay, so we've seen the macro shadow of the whole universe. Let's zoom back in to our specific cosmic neighborhood.
Right. Let's look at how we actually fit into this giant 6D machine.
We live in the Virgo supercluster, but I have a question about this.
Go for it.
In a 5D perspective, the source says parallel timelines flow like separate rivers.
Yeah, branching and flowing.
But in 6D, they freeze into a static crystal. So what exactly is the Virgo supercluster in this frozen 6D structure? I mean, it can't just be a city of stars anymore.
No, it's not. The source explains that the Virgo supercluster is actually a specific flat matrix layer within the 6D time crystal.
A matrix layer, what does that mean functionally?
It's essentially where all those parallel timelines that split off during the Big Bang reconnect. It acts as a massive cosmic nervous system.
Okay, the source uses this final analogy here that I think makes it super clear. The computer microchip.
Oh yeah, the motherboard analogy is brilliant.
Right, so if you look at a motherboard, millions of circuits are printed incredibly close together.
And to a 3D observer, they look like completely separate lines.
Exactly. But functionally, they are a single data platform. They run together.
Right. So in 6D, The immense empty spaces between the Milky Way, Andromeda, and the rest of the Virgo cluster.
They just disappear. Their timelines are compressed and printed together like circuits on a cosmic motherboard.
That's exactly it, a cosmic motherboard.
Yeah.
And the final physical mechanic here involves gravity again.
Right. Gravity is the cosmic stitcher.
Exactly. Like a sewing machine, gravity stitches these different quantum paths together,
holding the whole 60 motherboard firmly in place so it can process all this data.
It's an elegant mechanical solution to a massive cosmic mystery.
It really is. Okay, let's do a quick recap of this absolute mind-bending journey for everyone listening.
Good idea. We've covered a lot of theoretical ground.
So first, we basically flattened the entire JWST deep field into a single top-down slice of time.
Right, destroying the illusion of physical distance.
Then we saw parallel timelines literally shattering through the gravitational bridge of Pandora's cluster.
Using that cut diamond concept to see alternative realities.
Exactly. Then we zoomed out and realized the entire cosmic web is just a 3D holographic shadow of a static 6D crystal.
Structurally identical to the human brain.
Yes. And finally, we saw our own Virgo supercluster as this dense cosmic motherboard holding the data of past, present, and future all at once.
The ultimate takeaway for you, the listener, is just how profoundly connected you are to the cosmos.
It's honestly kind of comforting in a weird way.
It is. Because you might feel trapped in this 3D physical body dealing with mundane daily stress.
Oh, absolutely.
But your consciousness, your memory, your literal neural network operates on the exact same 6D geometry as the entire universe.
You aren't just in the universe, you are wired exactly like it.
That's the beautiful truth of this 6D perspective.
It's incredible. And, it leaves us with this final lingering thought to ponder long after this deep dive stops.
Oh, this is the really provocative part.
Yeah. If gravity is the only force capable of crossing dimensions to stitch alternative timelines together.
Right, traveling through the bulk.
And your brain physically mirrors this exact 6D cosmic network, does human consciousness possess its own form of cognitive gravity?
That is the big question.
Think about it. When you focus deeply on a single decision, are you literally pulling a specific parallel timeline into reality? Next time you make a choice, ask yourself what universe you're dragging into existence. Imagine for a second that you're holding a really high-powered electron microscope in your left hand.
Right, and then maybe a massive deep space telescope in your right hand.
Exactly. Two profoundly different tools, basically built to observe two entirely different realities.
Yeah, historically speaking, physics has always treated those two realms like they're just completely different universes.
Yeah.
They just happen to be living side by side.
Because if you look through the lens on your left, you are plunged into the quantum realm. It's this chaotic, jittery, almost totally incomprehensible world of subatomic particles.
It is incredibly chaotic down there.
Right, but then you look through the lens on your right, and you see the macro universe, the slow, majestic, just incredibly predictable gravitational waltz of all these stars and planets.
And for well over a century now, the greatest minds in science have just agonizingly tried to bridge the gap between those two things.
The rule books just do not match up.
No, they don't. You have quantum mechanics ruling the tiny stuff, and general relativity ruling the massive stuff.
Right.
They're essentially two different rule books that fundamentally refuse to translate. It's like they don't even speak the same language.
But what if they actually do? What if every single thing you ever learned about the microscopic atom and then the massive sprawling solar system, what if they were actually the exact same architectural blueprint?
Just viewed at drastically different zoom levels.
Yes, exactly. Which is a staggering thought experiment.
It really is.
So today, we are taking a fascinating stack of highly theoretical notes that blend hardcore quantum chromodynamics with macro astrophysics. And we are going to attempt to read both rule books at the exact same time.
Which is quite the undertaking, honestly.
Wow.
Quantum chromodynamics alone is, it's the incredibly complex physics of the absolute smallest things in existence.
Okay, let's unpack this because we are going on a serious journey with you today. We're going to travel from the invisible, unbreakable prison of subatomic quarks all the way out to the colossal gravitational ballet of our planets.
And uncover a pretty mind-bending connection between the two.
Yeah. But before we can even attempt to redraw the map of the entire universe, we have to understand those tiny building blocks first. We have to zoom all the way down into the atomic nucleus.
Right. So if we look at the very center, the nucleus of a standard atom, we see protons and neutrons.
Which we all learned about in high school chemistry.
Exactly. And for a very long time, science thought those were the absolute floor of reality, like the smallest possible indivisible things.
Right, like you couldn't break them down any further.
But you can. They aren't the floor. They're actually composed of even smaller fundamental particles called quarks.
Quarks, and there's a highly specific recipe to make them, right? It's not just a random jumble of quantum dust in there.
No, it requires a very, very precise recipe. So a proton is perpetually made of 2 up quarks and 1 down quark.
Up and down being the literal names physicists gave them.
Yes, physicists have a fun naming sense. And a neutron is made of 1 up quark and 2 down quarks. That is their permanent genetic makeup. But to truly understand how they behave and why they bind together in those specific groupings of 3, you have to understand a concept called color charge.
Which, to be absolutely clear to you listening, has nothing to do with actual colors.
Oh, definitely not.
Like, you wouldn't see it in a rainbow or on a paint swatch. It's just this quirky, slightly confusing naming system physicists came up with to describe a mathematical property.
We are strictly not talking about visual light here. Color charge is a fundamental property of quarks, functioning somewhat like positive and negative electrical charges.
Right.
But instead of just 2 options, like positive and negative, quarks actually have 3 options: red, green, and blue.
Okay, so 3 charges instead of 2.
Exactly. And the ironclad rule of the quantum universe is that no particle can exist in isolation unless its total color charge is completely neutral.
Which physicists call colorless or white.
Right. So inside a proton, you have 1 red quark, 1 green quark, and 1 blue quark.
And they combine in a way that just perfectly cancels each other out.
Yes, becoming a colorless, stable entity.
And you can never pull one of those quarks out to examine it on its own either. Like, they are completely locked in.
That phenomenon is known as quark confinement. You just simply cannot isolate a single quark in nature. It's impossible.
It's basically a microscopic prism.
It is. And the mechanics behind this permanent imprisonment are actually what won the 2004 Nobel Prize in Physics, revealing a concept called asymptotic freedom.
Okay, asymptotic freedom. Think of it like a wildly bizarre rubber band connecting 2 quarks.
A very weird rubber band.
Right, so when the quarks are super close together, just kind of resting against each other inside the proton, that rubber band is completely slack. They just bounce around, acting like entirely free, independent particles.
They feel virtually no force at all when they are in that close proximity.
But the second you try to pull them apart, that rubber band stretches, the tension builds. And unlike gravity or magnets, where the further away you get, the weaker the pull becomes.
Right, gravity falls off with distance.
Yeah, but with quarks, the further you pull them apart, the strictly stronger the force becomes. It pulls back with a violence that completely defies logic.
And should you somehow apply enough energy to finally snap that rubber band, pulling them far enough apart to actually break the bond?
Which would take an insane amount of energy.
An unbelievable amount. The energy you use to do that is so massive that it literally creates brand new quarks out of thin air.
Wait, out of nowhere?
Well, it perfectly follows Einstein's E equals mc squared.
Oh, converting energy into mass.
Exactly. Converting your applied energy directly into mass, you don't get an isolated quark, you just end up with a brand new pair of quarks.
Wow.
And the mechanism holding that tension together, the literal glue of the universe, is a field of particles called gluons. They are the carriers of the strong nuclear force.
Now, this specific detail just completely rewired my brain when I read it in our sources today. The quarks themselves, the actual physical building blocks of the proton, only account for about 1% of the proton's total mass.
Yeah, what's fascinating here is the implication of that math.
Because it sounds impossible.
It does. But it means the remaining 99% of your physical mass, the mass of the chair you're sitting on, the mass of the entire Earth, it is not solid matter. It is strictly the kinetic energy of those gluons buzzing around furiously, just keeping those quarks imprisoned.
That is insane. So when you look in the mirror, you are essentially just looking at binding energy wrapped in a 1% shell of actual solid matter.
Pretty much.
Which is both terrifying and incredible. But wait, if everything is locked down that tightly, if this binding energy is so absolutely unbreakable, how does anything in the universe ever change?
That is the big question.
Right. How do these particles interact without just being stagnant little prisons forever?
Well, that leads us to the crucial concept of shapeshifting. Because despite this incredibly tight confinement by the gluons, protons and neutrons are not entirely fixed entities.
Okay.
Under the right circumstances, they can actually change identities in a process called beta decay.
Oh, right. So a neutron can spontaneously decay, literally transforming itself into a proton.
Yes.
And when it does that, it spits out an electron and an antineutrino to sort of balance the quantum ledger.
Exactly. Conservation of energy and charge. And a proton can also absorb energy and turn into a neutron, kicking out a positron and a neutrino.
So they are essentially swapping costumes at the subatomic level.
That is a great way to put it, yeah.
But if these fundamental particles are just constantly shape-shifting into each other, why isn't the desk I'm sitting at dissolving into a chaotic radioactive soup right now? Like, why is solid matter stable at all?
Well, because it requires incredibly specific, really extreme energy conditions for a proton to turn into a neutron. That reaction doesn't just happen ambiently on your desk.
Thank goodness for that.
Yeah, it actually happens inside the crushing pressure and apocalyptic heat of a stellar core. In fact, beta decay is the literal engine of our solar system.
Wow.
It is the exact fundamental process that allows nuclear fusion to happen, igniting the sun and keeping it burning.
So the sun is essentially just a gargantuan factory of protons and neutrons swapping identities under immense gravity.
That is exactly what it is.
But what about that electron we mentioned? Like, it gets spat out during beta decay, but it's a totally different beast from the protons and neutrons, right?
Completely different. The electron is the ultimate outsider in this atomic model. It is not made of quarks, it doesn't experience color charge, and it absolutely doesn't feel the strong nuclear force.
It just ignores it.
Yep. It belongs to an entirely different family of elementary particles called leptons. It operates purely on the outside of the nucleus, orbiting in a cloud, and it is almost impossibly lightweight.
How light are we talking?
An electron is roughly 1,836 times lighter than a single proton or neutron.
Okay, so let's lock in this micro-world map. We have heavy quark-filled protons and neutrons, shape-shifting in the dense center, held together by the furious energy of gluons.
Right.
With these incredibly lightweight outsider electrons buzzing around the vast empty space on the outside.
That is the micromap, yes.
Now, we are going to take those exact mathematical rules and map them onto the macro solar system.
And this is where the notes get incredibly theoretical and, frankly, breathtaking.
Yeah.
The core thought experiment asks a simple question. What if the outer boundary of our entire solar system functions exactly like the boundary of a single cosmic proton?
So if the solar system's boundary is a macroproton, it absolutely has to be made of 3 macroquarks to fit the rule book.
Yes.
Remember the strict recipe you listening. 2 up quarks and 1 down quark. What could possibly represent those on a cosmic scale?
Well, according to this theoretical physics model, the first macroquark, acting as an up quark, is dark matter.
Dark matter.
Yeah, we can't see it optically, but its immense gravitational anchor holds the boundary of the solar system and the galaxy itself together.
Right, because the up quarks in a microproton provide the primary structural mass anchor.
Exactly, which is exactly how dark matter functions on a macro level. It's the invisible physical scaffold.
Okay, so the second macroquark, filling the role of the second up quark, is cosmic rays. The notes describe this as relativistic plasma, which is just a very dense way of saying it's a storm of incredibly high-energy particles.
Particles blasting into our system from the rest of the galaxy.
Right, moving so fast they almost act like light. And it maps perfectly because it represents the dynamic, energetic influx required to maintain the system's boundary.
It does. Now, the third macroquark, fulfilling the role of the down quark, is the space-time geodesic warp.
Okay, I have to stop you because space-time geodesic warp sounds like something out of a 1970s sci-fi script. Let's translate that for everyone.
Fair enough.
A geodesic is basically just the straightest possible path an object can take over a curved surface. So we are talking about the literal physical bending of space and time around our solar system.
Precisely. It is the topological curvature of space itself in 4 or 5 dimensions, acting as the geometric container for the other 2 macroquarks.
Here is where it gets really interesting, though. If the engine of our sun is just a scaled-up version of a tiny quantum identity swap, how far does that scaling go?
What do you mean?
Well, we just spent 10 minutes talking about quark confinement. We established it as an unbreakable law of physics that quarks are permanently trapped inside the proton.
Yes.
So how can we literally look up into space and detect these macro quarks? Like, we can measure dark matter's gravity, we can catch cosmic rays in detectors. How are they just scattered across millions of miles of space if they are supposed to be locked in a quantum prison?
The answer to that lies in cosmic expansion.
Okay.
This is the vital structural difference between the micro and the macro. In the micro world, space is incredibly, impossibly compressed, so the strong nuclear force is absolute. The prison doors are welded shut.
Because everything is so tight.
Exactly. But in the macro universe, space itself has been expanding outwards since the Big Bang. That literal stretching of the cosmic canvas has ripped the quantum prison open.
Oh, wow.
The expansion of the universe has basically torn the doors off the hinges, allowing these colossal quark energies to flow across a canvas so large that we can actually measure and detect them.
The universe is just a zoomed-in, blown-open atom. It is wild to think about.
It really is.
But if we're genuinely mapping the atom to space, we have to address a huge historical flaw in how we usually visualize this. Because since we were kids sitting in middle school science class, we've been taught this classic metaphor.
The solar system model of the atom.
Right. The sun is the central nucleus, and the planets are the electrons orbiting around it.
It is a very convenient, easy-to-draw visual, but physically and mathematically, it is completely wrong.
Why does that classic model fail so badly when we actually apply the math?
It fails mainly because of the law of conservation of mass. If we want this blueprint to be mathematically accurate across both scales, we have to look closely at the properties of the particles.
Right.
Electrons, as we established, have practically zero mass. Furthermore, their primary function when they perform quantum jumps is to emit light and pure energy.
And planets absolutely do not emit their own light. I mean, Earth doesn't glow in the dark on its own.
No, it doesn't.
And they certainly aren't massless. Jupiter is a colossal, unbelievably heavy, solid object. You can't just pretend a planet is an electron to make a pretty diagram. The math completely falls apart.
Exactly. So in this new unified model, we have to redraw the map entirely. The planets are not the electrons. The planets are actually the neutrons.
The planets are the neutrons.
Think about the physics of it. Neutrons have massive physical weight, just like planets. Neutrons are electrically neutral. They don't emit their own energy or light, just like planets.
Okay, that makes sense.
And crucially, in an atomic nucleus, the neutrons act as the heavy structural anchors. They balance the angular momentum of the system, so the positively charged protons don't violently repel each other and tear the atom to shreds.
Which is the exact role the heavy planets play. Their massive gravitational weight anchors the angular momentum of the entire solar system, just keeping the whole celestial family balanced and preventing it from flying apart.
Okay, so if the massive planets are acting as the neutrons, that means the sun itself has to be the proton.
Which fits the data perfectly. The sun holds roughly 99.8% of the physical mass of the entire solar system, consolidated right at its core.
Wow.
It is the massive central anchor, functionally identical to a proton in a hydrogen atom.
But I'm stuck on a thermodynamic detail here. Earlier, we said electrons are the things that emit the light and energy.
Yes.
If the planets are neutrons and the sun is a giant proton, they're all just massive physical objects. Where does the actual sunlight come from in this model? Doesn't the mass of the sun eventually just disappear into energy, completely ruining the proton comparison?
That is a phenomenal question. And if we connect this to the bigger picture, the answer is rooted in Einstein's E=mc².
Oh, well, we're back to that.
Yes. Matter doesn't just vanish into nothingness. Inside the sun's core, that nuclear fusion we talked about is happening constantly. Protons are violently smashing together.
But during that massive fusion process, all of that physical matter doesn't just spontaneously turn into light.
Only a fraction of it converts.
An incredibly tiny fraction. Only 0.7% of the physical mass involved in that fusion reaction is actually converted into solar radiation.
Which is the sunlight and heat that warms the Earth.
Exactly.
Wait, only 0.7% of the mass is converted to light?
That is it. The remaining 99.3% of that mass stays exactly as it is. Heavy, physical matter.
Wow, okay.
So the sun remains a massive, stable, physical proton. It just continuously sheds a microscopic 0.7% fraction of its mass as highly energetic light.
And that roaming energy acts as the electron equivalent in our cosmic atom model. The mass problem is completely solved and the scales align perfectly.
They do.
Okay, so we have massive planets acting as neutrons and a massive sun acting as a proton, with sunlight playing the role of the energetic electron. But in a microscopic atom, the fundamental force holding the proton and neutron together is the strong nuclear force. But out in space, the force holding the sun and planets together is gravity.
Right.
How can the architectural blueprint be the same if the fundamental forces holding the blueprints together are completely different?
Well, that brings us to the final and really the most profound revelation hidden in these notes. What if gravity and the strong nuclear force aren't actually different forces at all?
Wait, really?
What if, on a purely mathematical level, they are geometrically identical?
Okay, my brain is warmed up and ready. Walk us through how gravity and the strong force could possibly be the exact same thing.
Let's analyze the geometry. In macrospace, Einstein taught us that a supermassive object like the sun creates a gravity well.
Right.
It literally warps the fabric of space-time into a deep depression, like an invisible funnel, and the planets roll continuously around the curved edges of that funnel.
Instead of the tired old bowling ball on a trampoline metaphor, think of those giant plastic coin funnels you see at a science museum or at a mall.
Yeah, that's a good one.
You drop a coin in, and it spirals endlessly around the curved edges of the gravity well, never flying off, then never quite falling straight down into the center hole.
That is a perfect visualization.
Yeah.
Now, let's look at the microworld. Quantum physics tells us that the strong nuclear force creates what is called a nuclear potential well.
Okay.
It is a localized quantum depression where protons and neutrons get trapped together in a confined space.
So the gravity well in space and the nuclear potential well inside the atom are essentially the exact same geometric shape.
Geometrically, yes.
Yeah.
But there's a mechanical problem we have to solve here. If they are spiraling in a well, why don't they eventually crash into the center?
Well, in the solar system, the planets don't fall into the sun because of centrifugal force. Like, their immense orbital speed keeps them pushed out against the curve of the funnel.
Exactly. And in the atom, there are no orbits in a nucleus. Why don't neutrons just crush violently into the protons under all that immense pressure?
Oh, right. Why don't they?
Because of a fascinating feature called the repulsive core. The strong nuclear force pulls nucleons together relentlessly. But if protons and neutrons get too close, specifically, if they cross a distance threshold closer than 0.7 femtometers.
Which is unfathomably small.
Yes. The force suddenly flips its polarity. It violently pushes them away. It transitions from intensely attractive to incredibly repulsive.
So in both the macro solar system and the microatom, there is a physical or geometric barrier that absolutely prevents the mass from collapsing into the center. They are held in this perfect, delicate suspension.
They are. And this structural overlap isn't just some fun visual coincidence. A theoretical physicist named Juan Maldacena mathematically proved this connection in the late 90s.
Okay.
It's a landmark concept called the ADSEFT correspondence, sometimes referred to as holographic QCD.
Holographic QCD. That sounds like a concept that requires 3 PhDs just to pronounce correctly.
It is incredibly dense math, but the core concept is elegantly simple. Maldacena essentially discovered a translation dictionary between the two rulebooks.
Right.
He showed that the incredibly complex mathematics of the strong nuclear force, which operates in our standard 4-dimensional quantum world, is mathematically identical to the mathematics of pure gravity operating in a 5-dimensional curved spacetime.
So what does this all mean? If you're listening right now and feeling like 5-dimensional math is a bridge too far, let's ground this with a visual.
Good idea.
Imagine you have a 3D object in your hands, like a solid cylinder. If you shine a flashlight on it from the side, its shadow, projected onto a 2D wall, looks exactly like a flat, solid rectangle.
Right.
But if you take that same flashlight and shine it from the top down, its shadow on the floor looks exactly like a flat circle.
A rectangle and a circle, two completely different shapes, governed by completely different rules of 2D geometry.
But they are actually the exact same object. They are just a single 3D cylinder projecting its shadow into a lower dimension from entirely different angles.
Yep.
So what Maldacena is saying with holographic QCD is that the strong nuclear force and gravity are basically just two different lower dimensional shadows cast by the exact same 5-dimensional object.
That is the absolute perfect way to understand it. They look different to us because our instruments are observing them across vastly different scales and dimensions. But at their core, they are the same fundamental force.
That is just incredible.
The quantum glue that is currently holding the very DNA in your cells together, basically preventing the atoms in your body from flying apart, is geometrically the exact same force tying the Earth in its orbit around the sun.
Wow.
We have scaled all the way from a microscopic distance of 0.7 femtometers up to the billions of kilometers at the icy edge of the solar system, and the architectural blueprint holds perfectly.
It is a stunning, perfect symmetry of reality. The universe isn't some chaotic, disjointed mess of different rules for different sizes, It's a fractal.
A fractal, I like that.
It just repeats its brilliant design at every conceivable scale. Which leaves me with one final lingering thought for you to take away today.
Oh, based on where this logic naturally leads, I think I know where you're going with this.
If you look through that electron microscope and you suddenly realize that our entire colossal solar system functions exactly like a single solitary atomic nucleus,
Yeah.
then what happens when you look back through the Deep Space Telescope? What is the larger molecule our solar system is forming as it structurally bonds with other star systems across the Milky Way?
It strongly suggests that the macro universe might have its own entirely undiscovered version of cosmic chemistry, operating on scales we are barely beginning to comprehend.
We might just be one tiny, unassuming atom in a universe-sized drop of water. It's definitely enough to make you look up at the night sky and see something completely entirely new.
Absolutely.
Thanks for joining us on this deep dive. See you next time.